Okay, so next, we are now tackling the scalar quantities. Again, we are in part one for physics review, which is the basic mathematical techniques and formula manipulation. So what is a scalar quantity? A scalar quantity I describe only by magnitude alone. So there's only need to have the magnitude, and they do not have direction of action. Here are the examples of scalar quantities. We have the length. I had written here the units, which is the meter. Time is seconds. So notice you don't need to state, for example, you say for 4 seconds. You don't need to say if it is north, south, or 20 degrees above the x-axis. You don't need that because we don't need direction for it. So these scalar quantities, such as for example, volume, you don't need direction for that. Speed, the unit is meter per second. We also have the mass, the density, pressure, the unit is Newton per meter square or pascals. The temperature, take note for the temperature, we have Celsius, Fahrenheit, Kelvin. The other unit would be Rankine. How about for work? For work, we have Newton meter as our unit or joules. Another synonymous term for work would be energy, but we're going to tackle that further later. And the unit of energy is also Newton meter or joules. It can also be stated with kilowatt hour or sometimes in terms of calories. We also have the power, which is joules per second, or power known as watts. We also have entropy, which is joules per Kelvin, intensity, which is watts per meter square, and also for light intensity, we have the candela, and we have the number of particles, which is moles. So take note, all of these are scalar quantities because we don't need direction for that. Now, let's try now to discuss later the vector quantities. Once we say vector quantities, we have here the measurements with magnitude and direction. So later, I'm going to discuss it in details, but usually, what are the vector quantities? So for example, we have here the velocity. Velocity is different from speed because once you say velocity, we need to emphasize direction. For example, 3 meters per second north. We also have acceleration, wherein the unit is meters per second square. We also have forces as a form of vector. So all of these are vectors simply because it needs magnitude plus direction. So you just need to memorize this part, magnitude plus direction. Now, it will be easier if you will be familiarizing yourself from scalar quantities. Now, let's look at the example. Example 1. Which of this unit is a scalar quantity? Of course, the answer here is letter B, mass, because it doesn't need uh, direction. Force, velocity, and acceleration are all vector quantity. Okay, next, number 2. A car travels 6 meters north, then backs at 8 meters south. What is the distance traveled? Take note, distance, it is a scalar quantity. We are not asked for displacement. So once we ask for the distance, we just add them up. So the answer here is letter A, 14 meters. Now, how about this number 3? Which of this unit is not, take note of the word term, not a scalar quantity? So we have to look for a vector. Energy is a scalar, density is a scalar, mass is scalar. Therefore, the answer, it is velocity simply because it is a vector quantity which has magnitude and direction. Example number 4, which of this unit does not belong to the group? So look at this part. So joules is for energy, which is a scalar quantity. Watts, it's for power. And Pascal is for pressure. So all of this, it does not need direction. So letter A, the answer here is Newton because force is a scale. Force is a vector quantity. Okay, so and that's it. You can answer this practice set. You can pause the video and try to answer some of these practice sets. Thank you for listening.